Hello and welcome. Today we are doing another question from LeetCode called Boats to Save People. It is a medium. Let's get started. You are given an array people where people I is the weight of the ith person, and an infinite number of boats where each boat can carry a maximum weight of limit. Each boat carries at most 2 people at the same time, provided the sum of the weight of those people is at most limit. Return the minimum number of boats to carry every given person. Example 1, we have 2 people, weight 1 and 2. The limit for one boat is 3, and we can put both of these people on the same boat. So we output 1 because we only need one boat, and their weight is 1 plus 2, which is less than or equal to the limit that we have. Example 2, 3, 2, 2, 1. 3 would have its own boat. 2 and 2 can't go together, but 2 and 1 can, so they're on their boat. And 2 would be its separate boat, so we have a total of 3 boats. Example 3, we have people 3, 5, 3, 4, the limit being 5. Every single person here would actually need their own boat, so we would output 4. So before we start, just in our mind, let's think of some edge cases. What is the best possible number of boats and the worst? The worst possible scenario would be when every single person would need to have their own boat. So if we have n number of people, we would need n number of boats. But the best possible, the minimum number of boats possible for a given problem would be n divided by 2. Every single person can be paired up. And of course, the n would be rounded up. If we have 5 people, we would need 3 boats at the minimum. 2.5 wouldn't be a thing. So what this question boils down to is how many pairings can we make? With a caveat that the weights of the people we are trying to pair, x and y, is less than or equal to limit. So say we have the following problem. People 1, 2, 4, 4, 5, these are the weights, and the limit is 5. What is the minimum number of boats required for this? Well, right off the bat, who needs to be on their own boat? Anything that is a limit itself can take 0 more weight, so they would need to go on their own boat. So 5 would be its own boat. And we know from the constraints that my video is blocking, we're never going to have a weight of someone exceed limit. Someone by themselves can always fit on a single boat. So now that 5 is its own boat, what's next? What can 4 go with? 4 can only go with 1 if limit is 5, because 4 plus 1 would be less than or equal to limit. So 4 and 1 can be a pairing. But what if we flip it? What can 1 pair with? Besides 4, it can pair with anything else. So it can pair with either 2 or 4. 1 has 2 options, 4 only has 1. What we're going to do is take the biggest weight and pair it up with our smallest available weight. And this is going to be a greedy approach that we're going to take, because if 4 can't pair with 1, it can't pair with anything else, and it would need its own boat. So if a pairing can be made, we're going to make that right away. And all a greedy approach states is that we're going to get one of the optimal solutions. There may be more, but the way we're approaching it, we're guaranteed to get one of the optimal solutions. And it's going to be a little bit clearer as we go through this problem. So 4 and 1 can be paired together. Once that happens, 2 and 4 are left, and they can't pair together because they're going to exceed limit, so they also need to be on their own. And we have a total of 4 boats here. But let's say instead of 4 and 1 going together, we did 1 and 2. So here they would be their own boat. Then we have 4 and 4 left, which again can't be paired together, so they also go individually. Both of these solutions output a minimum number of 4 boats. So both of these are optimal. Our approach just means that we're guaranteed to be one of the optimal solutions. Say we had the following example. 1, 2, 3, 4, 5, limit being 5. Here, 5 would have to be its own boat. It's the biggest number we have, and even the smallest addition to that would exceed limit. So now our biggest is 4, smallest is 1, and 2, 3 are in the middle. 1 can go with 2, 3, or 4, and 4 can only go with 1. If we put 1 and 2 together, then 3 and 4 would have to be on their separate boat. And we would have a total of, let's see, 1 and 2 would go together, 3 would be its own, and 4 would be its own. We would have a total of 4 boats. But instead, if we pair the biggest with the smallest, 5 would be by itself, 4 and 1 can be together. And now that these are together, 2 and 3 can also be together, and we would have 3 votes instead. So always we take the biggest away with the smallest. If those can't work, so if 5 and 1 can't go together, we know the biggest can't go with anything else and would be on its own vote. Then we see the smallest with the next biggest and continue through from there. Once these are paired up, we move on to the next smallest, next biggest, and try to pair those up. So let's go ahead and code all of this up. So the very first thing we want to do is sort, right? We want to know what the biggest and smallest weights of our people are going to be at all times. So people.sort sorts it in increasing order in place. And we're going to initialize votes to 0, and at the very end, return the number of votes needed. And now what we want to do is have 2 pointers at the beginning and end, and we're going to have them meet. So they're going to be looking at the max weight and the minimum weight we currently have and seeing if pairings can be made up. So our beginning pointer, start and end, start is going to be 0, and is going to be length of people minus 1. While they don't meet, so while start less than equal to end, while there's still people to be paired up, if the weight, so if people of a start of the smallest person, so people plus start, and the heaviest weight, so people end, is less than equal to limit, a pairing can be made. So vote plus equals 1. And now we bring our 2 pointers in. So start plus equals 1 and end minus equals 1. Otherwise, if they exceed a limit, then the person with the heaviest weight will have to be on a boat by themselves. So still we're going to increase the number of boats we have and move the end pointer down. So end minus equals 1. And this means that the end person is going to be on their own boat, and we're going to see if the person with the smallest weight can now pair up with the second biggest or heaviest person. So here we can actually refactor this because boat and end, we're doing the same operations in both if-else condition. So what I'm going to do is just get rid of this, and instead boat plus equals 1 and minus equals 1, and return votes at the very end. So talking about space and time complexity. For space, we sort this in place and then just use 2 pointers. So this is going to be constant O of 1 space. For time, we sort n log n and then iterate through once O of n, giving us a total of n log n time complexity. So let's go ahead and run this code and run through one more example at the very end. Let's see, local variable boat. This should be boats. Accepted and submit. And accepted as well. So now let's go ahead and run through a problem from an example. Let's do the problem we did earlier. So 1, 2, 3, 4, 5, limit being 5. And let's throw in another number 2 here. The first thing we are going to do is sort everything. So this is going to be 1, 2, 2, 3, 4, 5. Votes is initialized to 0. And start and end pointers. Start will be 0 and will be the length of people minus 1. So the length right now is 6 and end is going to be at index 5. So while these two have not met, if, let's see, our pointer start is here and end is here. If the sum of the values at these indices is less than or equal to limit, so 5 plus 1, it's not less than or equal to limit, what we are going to do is increase the number of votes we have and move our end pointer down. So this is end pointer. That means 5 is on a boat by itself. So to visualize this, 5 is on its own boat here. And end is now at index 4. So now we go through this loop again, right? 1 less than equal to 4, so we go back in. 1 plus 4 is less than equal to limit, so we move start up as well. Start is now at index 1. And we increase votes by 1. And we decrease end by 1. So this is now at index 3. This means that we just formed a boat with 1 and 4. Now start is at 2, end is at 3. We go back into this while condition. If 2 plus 3 less than equal to limit 5, which it is, start moves up. So start moves up here. And boats increases by 1. Start is now 2, end is now 2 as well. So both of them are right here. And we just made a pairing of 2 and 3. Now, start is less than equal to end. They're both at 2, so yes, we go back into this while loop. 2 plus 2 less than equal to limit. At this point, it doesn't even matter. We know this person is going to be on their own boat. So yeah, we can move start up anyways. Boats will increase by 1. So this is 4. And decreases, this is 1, this is 3. And essentially the pairing we made right now was 2 by itself. And we have a total of 4 boats. So this is how we solve this problem. If you have any questions at all, let me know down below. Otherwise, I will see you next time.